This is BMAT 2021, Section 2, Question 10. So we have an inorganic salt which, when burned in a flame test, produces a lilac flame. When the salt is dissolved in water and sodium hydroxide is added, we form a green precipitate. And when it's dissolved in water and we add hydrochloric acid and barium chloride, we form a white precipitate. And our question is to find out what could be the formula of this salt. So we're given some information about various tests we've done with it, and this should give us some idea of what the salt is made of. So let's go through these tests one by one to see what information we can gain from this. So let's start with our flame test. When we burn the salt, we get a lilac flame. We should know that flame tests are to find out what metal ions are in a particular compound. So what would a lilac flame give us? Lilac is characteristic of potassium, so we know that K+ must be involved in our salt somewhere. If we go on to the next test, we see if we add sodium hydroxide to a solution of the ions, we get a green precipitate forming. So a green hydroxide precipitate is indicative of iron 2, so we know that Fe2+ is also in this compound somewhere. And then finally, if we add some hydrochloric acid and some barium chloride to a solution of our salt ions, we get a white precipitate. And there's only one thing that forms a white precipitate with barium, and that is sulfate. So we know that these three ions must be in our salt. If we look to our answer sheet, we can see there's only two salts that it could possibly be. We have this one here, KFeSO42 and K2FeSO42. But which one is it, and how do we work it out? Well, we can use the charges on our ions to see which of these is the correct answer. If we add them together, the net charge on our salt should be 0. So let's look. For our first one, we know that K has a +1 charge, iron has a +2, so that's +3 altogether, and our two sulfates will have an overall -4 charge. If we add these together, we get a net charge of -1, which is not what we're looking for. We're looking for a net charge of 0, so this is probably not going to be our salt, but let's just check to see if this one is correct. We're going to have an overall +4 here from our two potassiums and our one iron, and then a 4- for our sulfates. And if we add these together, we get a net charge of 0. So this is the salt we're looking for. This is our correct answer, which leads us to a final answer of H.